ACC
Okay.
should be good.
You're taking that next Wednesday?
This Saturday.
Oh, really? Okay. I just had another student that was going to take it on the 23rd, which I think is next Wednesday. They were going to take it next Wednesday for sure. I was surprised that it wasn't a Saturday. I bet you wish you were.
That's kind of weird.
I bet you wish you were taking it on a Wednesday too, huh?
Yeah.
All right. Let me pull it up here. Yeah, I guess nobody has school that day except the people that are taking the ACT.
Yeah.
Test 1, number 19. That's about there, I think. Yep. Now, occasionally I will forget to update this. So if you spot us doing problems that we've already done before, holler. I do these problems with so many students that I can't always remember exactly. I don't think we've done 19.
Okay, yeah, it doesn't look like it.
Yeah.
Oh wait, actually we might have. Wait, maybe not. We did something like this though.
Yeah, this is a pretty unusual problem. Let's do it, and then if we've done it before, you'll remember.
Okay.
Because the answer is a little, it's a little tricky. It's not quite what it appears to be when you first read it. So read it carefully, first of all.
Okay, $8.99 each. Sales tax 21.
Do you have your calculator handy?
Change rate. Yes, I do.
Okay. Figure up the total purchase price, including tax. Okay, let's actually talk about that. That's the price of the 2 lamps, right?
Yes.
So how do I add 7% tax to that?
I'm not great at percents.
Okay, we can't use percents in equations. So we have to, anytime we see a percent, we have to convert it to a decimal. What is 7% equal to?
0.7.
0.07.
0.07.
0.7 would be 7/10. That would be 70%. In other words, the difference between percent and decimal is you move the decimal 2 places.
Okay.
So I refuse to believe anybody can be bad at percents. Right?
So then you just add that on?
Hold on. Let's first of all clarify percents.
Okay.
When somebody tells me that they're bad at percents, that's almost an impossibility because you do one thing and one thing only when you convert from percent. You move the decimal point 2 places. So the decimal point is right there. Well, I got to move it 2 places. That puts it right there, meaning I need a 0 right there. Okay?
Okay.
If I'm converting, so what is 65% equal to?
65 is 0.65.
Okay. That's all there is to do to convert percents to decimal. Is just, move the decimal point 2 spots. So now how do we add 7% tax to this? There's 2 ways to do it. If you're manually doing it, the easier way might just be multiply it by that, and whatever I get, add it on to the purchase price. But that's the same thing as multiplying it by 1.07. And since you're using a calculator anyway, we might as well do it the way that is the least number of steps. Multiply that by a dollar 1.07.
It is 19.23.
Okay. Now multiply that number by just 0.07.
It's 1.25.
Now notice that I need to, that's the tax, right?
Mm-hmm.
That's the 2 lamps.
Oh, so that's what you would add on.
Exactly. That will add to 1923. In other words, multiplying by 0.07 and adding it to that is the same as multiplying by 1.07. Well, which is easier? This is 2 steps. This is only 1 step. So we would multiply by 1.07. Now, we're not done yet. This is a fairly tricky problem. Read the last 2 sentences and tell me what the answer is. And let's cover up the multiple choice.
Okay, hold on 1 second.
It doesn't mean probably what you thought it meant the first time you read it.
Okay, wait, read the last sentence?
Last 2 sentences.
Okay, you have $21 bills. How much will you need in coins if you want to have the exact change ready? And you want to have 24 because you rounded to the nearest cent.
Yeah, that 23 was really 24 because it needed to be rounded off. And so 24 cents is the answer. My point is that notice how easy it would be to read this, that you have a $20 bill, how much change do you get? Well, how much change you get? You get 76 cents change if you give them a $20 bill, and that answer's on there.
Okay, yeah, so it's $21 bill.
I guarantee you half the people are going to answer that right there.
Okay.
Because they don't read the last 2 sentences carefully enough. The typical question is you give them a $20 bill, how much change do you get back? So that's what you're expecting when you read it. But that's not what they're saying as you figured it out. Now, let's go back here and talk about taxes. If I have a 7% tax, I'm going to multiply the purchase price by 1.07. Now let's talk about discounts. How do I figure out if I have something that's priced at 20 bucks and I want to give a 20% discount? How do I figure out that? In other words, this is where we're adding something to it, a premium, but this is where we're discounting something.
Okay. So 20% would be 0.20.
Okay.
So then what I would do for this one, or the thing that makes the most sense to me would be to multiply it. I know this is like more steps, but by 0.20 and then just subtract that from 25.
Okay, that's 20 bucks. So that's correct. That's the one more step. What would be a better thing to multiply it instead of 0.2? How about 1 minus 0.2? In other words, the other one we did 1 plus 0.07 to get 1.07. This one we're giving a discount, so if we multiply the whole thing by 0.8, we'll get our answer in 1 step and not 2.
Okay.
So that covers discounts and premiums. And they probably will have at least one question of each on this test. They'll have a question where you're paying tax, and they'll have a question where the store is giving a discount. You know, they're knocking 15% off everything in the store. So if you were knocking 15% off, I'd want to multiply everything by 0.85. Then I get the direct price. Okay? You're welcome to do these whichever way you feel most comfortable doing. I'll always point out the faster way, but that doesn't necessarily mean you have to use it.
Okay.
Okay, we got r cubed equal to 343. They want 3r. So what's the first thing I have to do? This is a two-step problem.
Well, I guess you'd want to solve for r.
Okay, good. How do I solve for r?
You do the cubed root of 343.
Good. Which is the same as taking 343 to the what power?
To the...
Because you got to do this in your calculator. You got to know how to do it.
Yeah, well, I just go down to, or I press math, and then I go,
okay.
right,
It's got a cube root function. It's the same as taking it to the 1/3 power. When you take the cube root of something. Just like when you take the square root of something, it's the same as taking it to the 1/2 power. In other words, when you have a fractional exponent, whatever that denominator is, you're taking that root of the number. And you can do this in the calculator this way. In other words, you can do 343 raised to the 1/3 power. What do you give for r?
7.
What's 3r equal to?
3r is equal to 21.
That's the answer. G.
Okay.
Okay? Almost all of these are going to be two-step problems. Again, you're going to have to figure out something and then apply that something to the rest of it. How am I going to list these from least to greatest?
From least, oh, I hate these.
They're easy. You have to convert them all to the same format. What format would that be?
Maybe decimal?
Okay, good. What is pi?
3.14.
Close enough. What is 7/3?
2.3.
And what is 9/2?
4.5.
Now rank them. What's the smallest?
2.3.
What's the next smallest?
Pi, and then 4.5, or 9/2.
So we've got 7/3, pi, 9/2, b.
Okay.
In other words, it was easy. It was the easiest problem as they come if you knew to convert all of them to decimal. Notice you don't have, it might be easy if I converted them all to fractions also with the same denominator. That would be a lot of work, plus pi doesn't convert to a fraction. That's the definition of an irrational number. Is it cannot be represented as a fraction. There is no fraction that is pi. None. Not in the entire universe. Can you give me a fraction that equals pi? All right. So the only thing we could actually convert all three of them to was decimal. That was what? 21. We doing a half hour tonight or an hour?
I think a full hour.
Okay. Probably a good idea if you're taking that test that soon. Okay, this is an interesting problem. So can you formulate this algebraically? Can you turn this word problem into an algebraic equation? Not that that's the easiest way to solve it.
Yeah.
But can you do it?
Perhaps. I feel like that'd be a lot of work. You'd have to
Actually, not so much. I'm going to show you an easier way to solve the problem, but I want to make sure you understand how to turn word problems into equations. First step, always, no matter what the word problem is, what?
What are you looking for?
Define your variable.
Okay.
X equals the number to be added to top and bottom, to numerator and denominator, because that's what the question says. We're going to take a number, add it to both the numerator and the denominator of 9/13, and we're going to get 3/4. So now that I've defined my variable, it should be relatively easy to set up an equation. What would the equation be?
Well then, what you would do, 9/13 plus x equals...
We're going to add it to the numerator and the denominator.
Oh, 9 plus x, and then 13 plus x.
There you go.
Equals 3/4.
Exactly. Now there's an equation with only one variable. We can solve that. We can cross-multiply it, gather our variables together, put all the x's on the left side, the numbers on the right side, and we'll solve it. Okay? Notice that once we define the variable, the rest of it just kind of fell into place. It's all about that first step. I can't emphasize that enough.
Okay.
However, there's an easier way to do this. Let's back solve it. Let's pretend, let's pick one of those answers and see if it works. What's the easiest number to work with?
Probably 3.
Yeah, any of the whole numbers, but not these two. That's going to make the math hard. But
right.
Let's see if 9 plus 3 all over 13 plus 3, is that equal to 3/4? And if it is, that's the answer. What is it equal to?
12/16.
Which is?
Which is 6/8, or 3/4. Oh.
Which is 3/4. There's your answer.
Okay, wait, let me write this down. Whoops. That was definitely way easier.
Well, partly because I picked the right number first. You're not always going to guess the right number. Let's say we pick 6 first. Is that equal to 3/4?
No.
Okay, so we rule out 6, and maybe minus 3 would be it. Is that equal to 3/4?
Minus 3, no.
Okay, so we'll try the next easiest, which is plus 3, and that happens to work. So the downside of back solving is you might have to try all 5 answers before you find one that works. Now, back solving works super good when you know which way you have to go. In other words, if I add 6 and I don't get 3/4, does it tell me that I need a smaller number or a bigger number? Not really. Not that easy to tell. When I get 15/19, I don't know whether I need to add less or more. So in a way, this is not the perfect back solving problem, because you really don't get a feel when you try one of the numbers. You don't get a feel as to whether to go up or down. Now, the best way to back solve is to start with either the second lowest or the second highest. And that was a good reason for starting with J, because not only is it a whole number, making the math easy, but it's the second highest also. And if J is not correct, and it tells us that we need a bigger number, we know K is the right answer without doing any more math. So back solving is extremely powerful, but more so when it tells you which way you have to go. And we'll come across problems that are like that. You'll see that when you try to back solve it and you don't happen to pick the correct answer, you know that you need either a smaller one or a bigger one. You'll know the direction most of the time.
Okay.
What's the slope between those 2 points? And if you want to know any single thing that'll help you on the test the most, this is it.
Is it 3/11ths? I believe.
Yeah. No. Sorry.
No?
No. Slope is defined as what?
Rise over run.
Okay. The rise is what?
Oh, it's 11/3.
There you go.
Okay,
In other
wait,
words,
okay,
it's
so
delta y over delta x. The change in the y compared to the change in the x, which turns out to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you can even reverse it like you did. You actually did y sub 1 minus y sub 2 all over x sub 1 minus x sub 2, which is fine to do, just don't mix up the directions. Don't put 1 minus 2 in the numerator and 2 minus 1 in the denominator. You'll get the wrong sign.
okay.
Slope.
Yeah.
But in your case, it was much easier to take this minus that divided by that minus that. You didn't have any negative numbers. You ended up with a positive 11 in the numerator and a positive 3 in the denominator. So we were much better off doing this one than this one. This one would have given us minus 11 over minus 3, which still equals 11/3, but it brings in those pesky negatives that you want to avoid if you can avoid them, just because they tend to make people make mistakes.
Okay.
And of course they put the trap answer on there. They put both 3/11ths and 11/3.
Yeah.
Prime numbers. How do we figure out the prime factors of that number?
Shoot, I feel like I'm forgetting this stuff.
Well, first thing you want to do is
divided by 2, isn't it?
Yeah, pretty much. You want to start factoring it. Okay, so if 2 is one factor, what's the other one?
19.
Both of those are prime, meaning there's no further way to go. I can't factor 2 anymore, and I can't factor 19 anymore. So that's the greatest prime factor of 38. Now let's look at 100. Factor that.
50, 25.
No. Well, 50 and 2.
50 and 2, and then 25 and 2. And then that's the lowest. So 25, I think.
25 factors into what?
2 and 12.5?
About 5 and 5.
Oh, 5? Oh, yeah, I forgot you could do that.
Okay. And all 4 of these are prime. So I know that 2 times 2 times 5 times 5 is equal to 100. So what's the biggest prime factor?
24.
No.
Oh, wait.
Here are your prime factors. Always the bottom of the tree.
Yeah, 5.
5 is the biggest one.
Mm-hmm.
So now, what
24.
is P plus F? 24. Okay, I see where you got the 24. You were a step ahead of me. Okay. I'm not going to say anything yet. They want to know what t squared plus v squared is. What's my first step going to be?
Let's see. First step would be to solve for t and v, I would imagine.
Can't do it.
It's kind of hard.
Yeah, it's kind of hard. So if you don't know what to do as a first step, do whatever you can do. What can we do here?
We could, maybe we could plug, or no, I keep wanting to say plug in numbers, but I don't know if that works.
PEMDAS. Think PEMDAS. Let's square the t plus v. There's a 2 there, so let's expand that. That's the only thing we can do. Okay, I mean, I could take the square root of both sides, and I could solve for that by taking the square root of both sides, but they don't want that. That doesn't help us any. They want t squared plus v squared. I can't get that from t plus v. But if we expand that, what do we get on the left?
T squared plus v squared.
Nope.
T squared plus... Wait, why not v squared?
Foil it.
Oh. Oh, yeah, okay. T squared... Wait, I always have to write this out.
Well, there's a way to memorize this, and you should, because it comes up so often that it's better to memorize it than it is to have to foil it each time.
Okay.
Let me tell you what it is. It's t squared plus 2 times t times v, always, plus v squared. In other words, rather than foiling that, just memorize it. It's always that. And a minus b quantity squared is the same thing, only it's a squared minus 2ab plus b squared. In other words, the only difference is that middle term. Instead of a plus 2 times both variables, it's a minus 2 times both variables. So memorizing that and this is huge, will be very beneficial to you. You won't have to spend time foiling it, which means you won't have to spend time writing it down. You'll know instantly when you see t plus v squared that it's this, if you have it memorized.
Okay.
So now, that's equal to 289, right? And they want to know what is t squared plus v squared equal to. They've told us that t times v is 30.
This one's so there's too many like variables.
Okay, well, here's the t squared plus v squared, right?
Right, yeah.
So the only thing, if I can figure out what 2 times tv is, I'll be home free.
Oh, okay. So 60.
Okay, so now I have t squared plus 60 plus v squared equals 289. Keep going. We're trying to solve for this over here.
And then I would subtract the 60, and that's 229.
That's the answer.
Okay.
And that's the only way I know how to do that problem. I don't think there's another way. If I take the square root of both sides, I solve for t plus v, but that doesn't get me anywhere. I can't really go from there. In other words, it's only after expanding that that I end up with a t squared and a v squared in the same equation. And since that's what they're asking about, that's useful. So that's definitely a step that looks like it's worth doing. In other words, I have to somehow come up with a t squared and a v squared. And I can do that by expanding that.
Okay. Is that like one of the harder problems, or? It
Probably.
Pretty
yeah, I would say that that is. I mean, if you were to say the problems are either easy, medium, or hard, I would say that this is the harder side of medium.
Okay.
But not hard. I would not classify this as the third degree of difficulty. That knowing what a plus b squared is a big thing. You want to do that. You want to know that by heart.
Okay.
I'll tell you why. What's this equal to? And I almost defy you to even give me an answer using your calculator. I'll bet you that would be tough. Agreed?
Yeah.
Okay. However, this looks an awful lot like a squared minus 2ab plus b squared.
Oh, yeah.
Which is a minus b quantity squared. What's a and what's b?
A is 100 and B is 99.
So what's this equal to?
Oh. That's equal to 1 squared.
Which is 1.
Mm-hmm.
So I was able to do that problem only because I knew this. If I hadn't had this memorized, I would not recognize what I'm looking at there. And I would have one choice only, and that's to somehow try to stick this into my calculator and solve it. But like I said, that's going to be a lot harder than it looks.
Okay.
So memorizing that other, they're going to ask questions like this to see whether you have it memorized. That's how important it is to memorize. All right, so this problem here, we have x to the 3a plus 5 all to the 4th power equals x to the 44th power. And they want to know what a is.
Man, these are getting kind of tricky.
Not really. This one's actually pretty straightforward. This would be on the easier side of medium. What's the only thing we can do? Again.
Well, looks like the factoring.
No, it's not factoring.
The a.
We've got x taken to an exponent, all of it taken to another exponent. How do we handle this?
What we just did.
No. If I have 2 to the 3rd power and I raise it all to the 4th power, how do I solve that? What's that equal to? Not a number, but 2 to what power?
To the 12?
Yes, I multiply. In other words, when I'm doing double exponentiation, let's call it that, because this is one exponentiation, this is the second one. So when I'm doing double exponentiation, I'm going to multiply the two exponents. That rule you want to memorize also.
Okay.
If I am multiplying two numbers, I'm not double exponentiating, I'm multiplying, then you add the exponents. You see the difference?
Mm-hmm.
Okay. So,
like flip-flops.
Well, I prefer to think of it as that if I'm multiplying, I'm going to add. If I'm dividing, I'm going to subtract. And if I am double exponentiating, I'm going to multiply. In other words, I'm always going to do to the exponents one level less mathematically. Addition is one level down from multiplication. Subtraction is one level down from division. And multiplication is one level down from double exponentiation. So it's really easy to remember if you remember that you're always doing one level less than what the base is doing. So tell me what this is.
Okay. Well, I mean, I understand that, but I don't understand how you do it with just the x's.
Okay, well, there's no difference between b and x. First of all, tell me what that is. I'm dividing bases.
Oh, okay, so you're subtracting. So b to the first, yeah.
Okay. So what am I going to do here? I'm double exponentiating.
So you're going to multiply,
So
or add.
I'm going to multiply.
Oh, multiply.
If I was multiplying, I would be adding.
Okay, yeah. So
Always, one way to remember it is you're never doing the same thing to the exponents as you're doing to the base.
Okay. Yeah.
In other words, 2 to the third times 2 to the fourth, I'm never going to multiply those exponents because I'm multiplying the bases. So I got to do something different to the exponents. I got to go down one level mathematically. That's 2 to the 3 plus 4. I'm going to add the exponents because I'm multiplying the bases. Well, here I'm double exponentiating, so I got to multiply the exponents. So what do I get when I multiply these exponents?
You get 12, or, yeah, 12a plus 20.
Okay. Now, if I have one base to an exponent equals the same base to a different exponent, what can I say about the exponents? What has to be true?
They have to be equal.
Yeah, it's the only way it can be. So now the problem becomes easy. Solve that.
Okay. A equals 2.
Good. And that is a problem. This is a problem I see repeatedly on every practice test I look at. If we go to practice test 2, we'll see one almost identical, only just with different numbers. The concept here is you have to get x to an exponent on both sides, x to a single exponent on both sides. So you have to know two things to solve this problem. You have to know how to handle double exponentiation, and you have to know that if you have one thing to an exponent equals the same thing to a different exponent, then the exponents are equal.
Okay.
Now, this problem bothers me that it's on there because I don't think there's any log problems on the ACT. But you've had logs. You've had logs.
No, we haven't done them yet.
You haven't done logs yet?
Not yet. And I think our math teacher was even saying that they don't have them anymore. They used to.
Ah, maybe that's the problem. This is an old test. This is like 5 years old. Huh, okay. Well, the way you solve this is x to the 2 power equals 16. X must be 4. 4 squared equals 16. In other words, whenever you have a log problem, you take the number on the far left, raise it to the power of the number on the far right, and it's equal to the number in between.
Okay. Can you use the calculator log thing?
Maybe.
Like what would you?
No, you really
couldn't. What would you punch in?
Your calculator only has common log and natural log. Common log is base 10. Natural log is base e, which is a number like 2.71. So this problem here is going to give you difficulty on your calculator. What you need to know about this is how to express that exponentially. And that's what I did, was I converted it to an exponential expression from a log expression. And the way you do that is exactly how I said, is you take the thing on the far left, the base, you raise it to this power, and it's equal to 16. So now, x to squared equals 16, I can solve that. Take the square root of both sides, x equals 4.
Okay.
You know the problems they're going to have on there that are not log, but they're close to log. Let's talk about them while we're talking about this. Let me do this one here. These are the kind of problems they now have on the ACT. Now, this is actually technically a log problem, but you don't solve it using logarithms. You don't have to. What this kind of problem really is there is a common exponential base between these two numbers. What is it?
3.
Yes. How can I express 27 using 3 as its base? That's 27 right there.
Okay.
Still got to put that x there. Okay? How can I express 9 using its base 3?
3 to the 3 squared.
Still got to put that exponent up there. Now apply the laws of exponents. What does this become?
So we're adding those.
No.
So
it's double exponentiation. We're going to multiply.
Oh, multiply. Okay. So then 3. Or so 27x.
No, we're not going to change it back to 27. We changed it from 27 to 3 for a reason.
Oh, okay.
What's this one equal to?
3 squared times 2x minus 1.
Okay, what are we going to do with the
x?
x?
No, 3 to the 4x minus 1.
Got to multiply everything. You got to multiply that 2 by that whole thing.
Okay, minus 2.
Now what can we say?
Now,
if 3 to the 3x equals 3 to the 4x minus 2, what has to be true?
well, the x's have to be the same. Or no, wait.
The exponents have to be the same.
The exponents have to be the same.
So 3x has to equal 4x minus 2. solve that equation?
Okay.
Tell me the process you're going through to solve that equation. Do it out loud so
okay.
I can figure out what's going on.
Well, I want to move the x's to one side, so I subtract 4x.
Okay, so what's the left side now?
Left side is negative 1x.
And what's the right side?
Negative 2.
Okay,
and
now solve for x.
Negative 2 divided by negative 1, which is 2.
Okay. Now, notice that that caused a little confusion. So how about if we put the x's on the right side and the numbers on the left? Well, if I subtract 3x from both sides, I got x over here already. And if I add 2 to both sides, I get that. So in one step, I get it instead of 2. And I don't have to deal with any of these nasty negative signs. In other words, there's no rule that says you have to put the x's on the left side. You want to put the x's on whatever side results in positive numbers, not negative numbers. If you can't avoid negative numbers, then it doesn't matter. In other words, if I made this a plus 2, then I've got to have negative numbers one way or the other. It's still a little quicker to do it moving the x's to the right. I can still do it in one step. Whereas if you move the x's to the left side, you get minus x equals 2. Now you got to do another step. You got to divide both sides by minus 1 to get x equals minus 2. Okay? So that's a helpful hint. You don't have to move the x's to the left and the numbers to the right. You can do it whichever way is most convenient.
Okay.
Here's another question that gets asked repeatedly. In test 2, they got 2 of these questions. In the first 15 questions, 2 of them exactly the same. Well, different numbers, but exactly the same thing.
One endpoint of a line segment in the xy coordinate.
Minus 2, 9, right there.
The midpoint of the segment is the coordinates 4, 4. Where the coordinates of the other endpoint of the segment.
So the other endpoint has to be about there. In other words, they're talking about a line.
Right.
Where that is the midpoint of the line. And what they want are what are the x and y coordinates of the other end.
Okay. I would say it'd be J.
Very good. In other words, you figured out that it was 6 between the x's, so it had to be another 6 to get to that x. And when you looked at the answers,
I also looked at, I mean, all the answers were, most of them were negatives.
You're right.
And then there was a 2.
Yep,
and it's the 2.
Yep. So it had to either be H or J, because if there's one thing we know, the x-coordinate is a positive number.
Right.
But let's examine, I'm glad I asked, because you want to know exactly how to do this. This number over here, well, whatever the x-coordinate is, that 4 is halfway between minus 2 and 10.
Okay.
Okay? And this 4 is halfway between 9 and whatever this has to be. By that logic, what is the x-coordinate? I mean, what is the y-coordinate?
6 more.
Well, no, we're looking at the y's now. That was the x's. The x's were separated by 6.
Right. Then there are 5. 5 more.
Okay, so what's the y coordinate?
4 minus 5, which is -2.
Which is what?
Oh, -1, sorry.
Very good. That's how you do the midpoint problems. And this, like I said, they're going to give you one end and the midpoint, and you got to come up with the other end. So
Okay,
this is the way to do it. In other words, the only thing you really need to understand is that that is halfway between the two x's, and that is halfway between the two y's.
Okay. And
you just have to make sure you're going in the right direction. In other words, when we did the x's, we were going left to right. In other words, we were moving 6 units to the right from -2 to get the +4, right?
Mm-hmm.
Which means we have to go another 6 units to the right to get to 10. We don't go back to the left. Well, when we looked at the y's and we were going from 9 to 4, we were going 5 units down, which means we have to go another 5 units down from 4. And that gets us down to -1. We don't add 5 to 4 to get back up to 9. In other words, we just make sure we go in the same direction that we had to go to from the first point to get to the midpoint.
Okay.
Okay?
Mm-hmm.
And let's see what one more looks like there. Okay, this is a good one. Let me blow it up a little bit. There are exactly 2 conic questions on conic sections. Actually, it's not even conic sections, it's just circles and ellipses.
Okay, yeah, I remember you talking about
There are 4 questions on trig, and there are 2 questions on circles and ellipses. And both the circle and ellipse questions, you have to know the general formula for a circle and an ellipse.
Okay.
What's the general formula for a circle?
I think it's x squared plus y squared equals r squared.
That's good. That's the general formula for a circle at the origin.
Oh. Well, I have the off origin one too.
Okay, that's the one you want to memorize, because that works for both.
Okay.
So what's the off origin one?
X minus h squared plus y minus k squared equals r squared.
And what is h and k?
Those are the, well, there's no, I think those are the center.
Yes, exactly,
Okay.
precisely. So notice that if the center is at the origin, both of these are 0, and you end up with x squared plus y squared equals r squared. Okay?
Okay, yeah.
This is more robust because it applies anywhere. So there's no real point in memorizing the x squared plus y squared unless it facilitates memorizing this. And it kind of does. It does make it, if you know x squared plus y squared equals r squared, it's a little easier to memorize this one. So, if my function is x minus 4 squared plus y minus 1 squared equals 14, what's the radius of that circle? Where's the center of that circle?
Oh, the center, oh yeah, the center is -4, -1.
Now, notice the general formula is x minus h.
Oh, so it's 4, oh, okay, 4, 1.
Right. So the center is at 4 and 1. But they didn't ask for the center in this question. We didn't even need to know that. They want to know the radius.
Yes. the radius would be, oh, the square root of 14.
There you go. That's really all you need to know about circles. Is you need to know the general formula, and you need to know what H, K, and R mean.
Okay.
Okay? While we're on the subject, I know it's after 9, but let me just write it so you have a chance to write it and memorize it. And then we won't go through a problem, but know that the general formula for an ellipse looks very much like the formula for a circle, which you would expect because it looks like a circle, kind of. The only thing is that it's divided by a squared and this is divided by b squared. So memorize this also. Notice there's no r because an ellipse doesn't have a r. What is a and b? Well, a is the long radius and b is the short radius. In other words, b is the distance from here to here, and a is the distance from there to there. And there is the formula, with h and k being the center of the ellipse. And the biggest difference is the right side is 1, not anything else.
Okay.
Okay? So memorize both of those two, and you'll get 2 problems right, the 2 conic section questions, which tend to be the harder questions. In other words, those are generally 2 pretty hard questions. If you don't know these formulas, you would have no chance. But if you know these formulas, they become easy.
Okay.
Okay?
Cool.
All right. I will talk to you next time.
All right.
Okay,
Great.
Thomas.
Thank you.
You're welcome. Bye-bye.
You too.